Hi everyone, let's begin in our studio factor analysis, or we can call it data reduction and reliability, how we have to check. So let me start. I'm taking same example that I had already explained you in SPSS the playlist, and you can see here same example I'm going to discuss over here. Data detection and skill reliability factor analysis. Example is this: an advertising firm was interested in developing a scale to measure the credibility of celebrities in public opinion so that the right celebrity could be chosen for endorsing products. So, based on extensive literature, they identified a list of 14 qualities which could be important for establishing the credibility of a celebrity in public opinion, and respondents were asked to rank the credibility of some popular celebrities on a scale of 1 to 5 with respect to those qualities. The data for 56 respondents are given here, and here is 56. It's too small a sample size. These are the 14 items we had measured on the basis of these characteristics. These are the attractive, classy, beautiful, elegant, sexy, dependable, honest, reliable, trustworthy, sincere, expert, experienced, knowledgeable, qualified. But here is, because this is for the demo purpose, I would like to show how you have to run factor analysis in our studio. So I have taken just 56 total sample size, 56 sample size. But thumb rule is, those are the how many number of these statements. In my case, 14 number of these statements. So accordingly, it should be multiplied by 10. So minimum sample size you required 140. If suppose you are taking 14 statements, so you have to collect at least 10 times of this statement. That should be your data. I mean, this is minimum, and maximum you can take up to, I mean, some people are saying that you can take it up to 20. Right, 20 multiplied by 14 multiplied by 20. So I'm sure, but in my case, this data sample size is too small. Just I would like to demonstrate how you have to calculate factor analysis in our studio. So let me start. I'm just opening up this data, right? So we can call it factor analysis, EFA also, exploratory factor analysis. And further, if you are going for structure equation modeling and regression, and if you would like to go for PLS-SEM, so you have to use further after this exploratory factor analysis, CFA also. So what is the relevance of this factor analysis? Let me explain you. In EFA, we are interested in exploring the underlying dimensions that could have caused correlations among the observed variables. And EFA deals with theory building. And here is, I am not using SPSS, I am using only RStudio. So let's begin. This is, I had already done something, right? So let me clean this. Since beginning we are going to start, let me clear this pane also, and this window also I am clearing, right? So shall we now start? And let me, this one is the, I'm just closing this file also, factor analysis, how you have to import this file. I would like to import this file, and this file is SPSS file, right? So let me browse this file, and my file that is in my RStudio. Let me open this and you can see here. Let me take my file. I'm just opening up this my Excel, this my SPSS file. That is in the right. I mean, this is the folder where I put it, this my RStudio folder and factor analysis. So let me open this SPSS file, and now I'm importing this file. So you can see here, this file is opened over here. You can see here, total number of the sample size is 56. Total number of sample size is 56. These are my parameters on the basis of which I had collected my data. All 14 parameters are here. So now, one by one, what we have to do, first of all, I would like to get the summary of this data. First of all, what I have to do, I would like to put this complete file in a one variable. Let me assign, there's the one variable name, that is FAC, and I would put this file, let's say factor analysis. This is the a bigger name, so I would like to put this file into a small variable. So what I have to do, you can see here now, this is the FAC. This is variable is created here, 46 observations, 15 variables are here. 15 variables, I'm sure, I mean, this one is the, you can see first line is resident ID, I mean, so respondent's ID. So respondent ID is showing, so that is why it's showing 15. Otherwise, variables are only 14. So now what I have to do, let me check summary of this data. Sorry. Let me check. Here is summary of this data, right? Summary of this FAC, this variable, and let me press enter. So now you can see this is the summary of this data. Resident ID, right? Attractiveness, minimum 4, first quartile 4, median 5, mean 4, third quartile 5, and maximum is 5. So in that way, all 14 parameters summary is here. Now, what I have to do, you can see here, next one is what we have to, we can check, I mean, we have to first of all establish library of psyche. You can see library, and what library we require to run this factor analysis. You can psyche, right? And we have to install this library, right? Now what we have to do, we would like to run KMO, right? So first of all, we want to check KMO test. Right, first of all, we can run this KMO test. So you can see here, you can see here, either you can see here in my console, I have shown you, this one is the factor analysis. There are some codes I had written here. And KMO, when I had, after installing this library Psyche and KMO test, you can see here, and KMO value in my case, and you can copy this result also in your Word document also. You can see here. This is my Word document file. I will copy this data and I will paste here in my Word document file. So I would paste here, right? Not this one. Let me copy and I would paste here, right? No, it's not copying. No, not an issue. So you can follow that video also, where is output directly going to the Word document. So KMO value is 0.78. It should be greater than 0.7. So in my case, that is acceptable. This is my KMO value. Now we want to check Bartlett test also. So we have core test dot Bartlett factor analysis. You can see here. You can see here. This is my chi-square 579.54 and a p-value, it is less than 0.5. That is also acceptable, and degree of freedom is 105. Now let me check correlation among all the factors. Correlation among all the factors. So simply I would write core and I will put this variable in this co-function and let me press enter. Now you can see what is the relationship among all the factors. Those factors I had already collected, all variables, parameters I have taken. You can see what is the correlation among all the variables. So now what I have to do, I would write PCA, right? Principal component analysis, and simply I would write FAC, comma, and this one is the n factor, right? How many factors I would like to take? So it would reflect n factors, right? You can see here n factors. I just want, like in SPSS, only 3 factors I require, because I have less number of factors. I have only 14 factors. So fine. Those are the 3 factors I require, but that should be unrotated. That I don't want rotated one. So what I have to do, I have to write F, because rotate false, and simply I would press enter. So now you can see when I had applied this command, this function PCA, right, factor and factors 3, rotate F, and you can see here all these standardized loading is reflecting over here, and you can see here cumulative variance here is 0.66. So that should be greater than 0.6. That could be acceptable. So in my case, that is also acceptable, 0.66. So that means it is greater than 0.6. So in my case, that is acceptable. So let me, I have to create one particular, we can check one particular variable value also. So what we have to do, let me please, okay, fine. I would simply, what I have to do, I will put all these values in this particular variable. So what I have to do, let me enter PCA, right? And again, I have to write FAC and comma and factor. Again, I have to write and factors. And factors here is, suppose you want to see one only one particular variable values, so you can leave blank. So that means automatically it would consider it as one only. That means you want to see only one component, I mean one variable analysis only. So rotate F, again unrotate it, and we have to press enter, and simply we have to press FCA and we have to press enter. So now you can see only PC1, right? Only one component it would reflect here, right? Rather than earlier we have taken at the three factors, we have taken those factors having higher loading, but here is only one factor loading is reflecting over here. So now what we have to do, simply again I have to put here is in this particular, in this f call, right? This is the one of the variable, and I would write PCA, write this function, and simply I have, what I have to do, factor and n factor, right? I want only all 3 factors over here. So what I have to do, 3 factors, right? And then I would write rotate, right? Rotate, and that should be false. So you can see here, and I would press here, and here is the FACL. Quickly, I have to run this simply, and then after that, I would run this, right? Now these are my all 3 components, on all these components values are here, same results you can see here, and I have stored all these values in fcall, right? Now I want to give, this one is the print command, so you can see print, we will write here print, right? Print, and after that what I have to do, I will call, because where I had put it all the values, f call, right? And I would press $sign, and after $sign I want loadings, and those loadings cut off, I will give cut off, that should be all are above 0.5. So simply I would press enter, and now you can see here those, I mean, PC1, PC2, PC3, right? First component, second component, and third component. And there is the all the this number is all are greater than 0.5 and VC2. But here is one of the important problem you can see here. There's the cross loading problem also. I mean, there's the one factor, it is falling in two components, PC1, and I mean, they are creating two factors, PC1 and PC3. This the cross loading problem is also reflecting. So how we have to remove this cross loading problem? And before that, let me check this communality also. So I would press FCAL and dollar sign, and here is communality also I have to press. So you can see here, you can check all these communalities also, all are greater than 0.5, right? And few, this is the 0.4 and there is the 0.4, rest all are. And after that, what we have to do, let me, here is once again, what we have to do, now we have to check these values, I mean, on the rotation, very max we have to, because we would like to remove this cross loading. So let me create one new variable where all these values would be, I will put it, then again, principal component analysis. And under this principal component analysis, I will call my file FAC. And again, I have to write factors and factors. And in n factors, you can see here, again, I want only 3 factors only, but it should be, now my question is rotate, right? Because very max I want to apply here, and I will press this and simply I would write very max, right? So because I want to remove this problem of cross loading. So what I have to do, FANA, and simply you can see now the diagonal values are 0.97. Now you can see here, right, there is, and you can see cumulative variance 0.66, and this is the cross loading value, that is principal component analysis, whereas cross loading problem is now no more is existing. So what I have to do, right now, I would write this command, this function, print function, and simply I have to run this, right? You can see here, earlier the same factors, they were falling into two categories, but now only, I mean, only they are falling in one particular component, they are creating only one factor. Right. So what I have to do now, again, we have to run this pcom, right? We will save this value in this. Again, now we have to create one more variable, and you can see here, I am going to creating this variable pcom equal to, and principal component, this function we are going to use principal component, and I have to write factor, and I want scores, and scores, that should be, we will write true, and what is correlation, we will write true, right? True. And we will run this function, and simply where we had stored these values, and we have to press enter. So standard deviation also, you can get all the 15 variables and 56 observation, these are the standard variables also, we will get it, right? And simply I have not removed, that one is the respondent ID, but you have to remove only 14 variables, you have to take. And what we are doing now, I want to plot, right? So simply I will use plot, and we have to, where I had put it all these, so pcom, right? I had put all these values in pcom and I would press enter. You can see this is the plot is, you can say variance is 5. I mean, these are the components, component 1, 3, 5, 7, 9. And now what we have to do, I would like to give them one color also, right? So what I have to do, simply I would like to give color. Let's say I want to give color C, and I want to give color, let's say 7. So I would press enter. So now you can see this is the yellow color. I mean, that is reflecting over here. And what we have to do, suppose I want to get the scree plot also, three scree plot you have seen in SPSS also, scree plot, right? Simply I would write a scree plot, and this is the file is put it over here, pcom, and type, what type I want scree plot, simply I want line, right? And simply I would I want line, so I have to write here line plot I require. And let's say I have to give this particular plot as uh, title also. So I would say this is scree plot, scree plot, or I would write scree plot for uh, factors. This title I want to give, right, for factors, right? Simply I would press enter. No, I think okay, fine, sorry, this is the one mistake. There is the main, whatever is the you want to write this string, so you have to, that should be closed into inverted commas and double quotes. So simply now you can see the scree plot for factors. Now what I want to give color to this particular, you can see first component, first factor, second factor, and there is the third factor, right? And now you can see here I just want to give color to this line also. So simply I have to write col, and let's say I want to give color, let's say 4. So I would press enter, and you can see here, okay, fine. This is the blue line. Now earlier that was the colorless line, and now this is the blue line is here. So I'm sure both these plots and both these curves, you can, how we can zoom this, right? And you can see this is the scree plot, and what you have to do, simply you can report in your research paper and copy to clipboard, and we have to copy and we have to report here in my Word document also. What happened? Let me once again, I will copy to clipboard. I had pressed copy plot, and simply I would delete this, and simply I would write to paste here, right? So this script plot you can copy and paste. And the same way, suppose when we had created that plot also, that one is I think we had given the blue one, na? Right? This plot also, simply you can see in the zoom form, and as well as what you can do, you can copy to clipboard, copy plot, and you can report in your this your Word document, right? In that way you can paste here. And same way, I'm sure you could be able to report your analysis, report your result, how you had reported in your SPSS, because there is the three components, three factors has been identified, right? They are making these loadings. So in that way, you can say factor one, right? 1, 2, 3, 4, 5, 6. These are the six factors. These are the six variables are falling in this particular. They are making this particular factor, and this one is the second one. 1, 2, 3, 4. These are the making, and third one is this. So you can give them any name, right? I had like in SPSS, I had already given these names. You can see here. I'm just showing you. 10 statements, factor analysis, right? And I have already shown you these factors name I had already classified, right? Same way you have to report here, right? Whatever the factors, like factor 2 is the flies. This one is, I think, no, that one is the right, this one is the case. So let me explain you how I had reported this thing. Like I said, first one is the, I had given first factor trustworthy, right? Those are the component values are here. And I second factor I said expertise, third factor, those are falling into attractiveness. So right, in that way I had mentioned, right, all these parameters, those are making this particular factor. So I'm sure this video would be helpful to you, and definitely I'm going to share some more SPSS analysis in RStudio. And till the time, keep watching. Thank you so much.